Okay, so let's get into our vertebrae discussion. We're going to start with what's called a typical vertebrae. We call it a typical vertebrae, and you also have this in your responsibility list because all of these structures here are found in all the vertebrae, whether it's a lumbar, thoracic, or cervical. Sacrum's just a little bit different. We'll come back and talk about the sacrum later. But in your responsibility list, there is a line, I believe, that goes between body and pedicle this way. And the reason I like to put that line there is because when you look at a vertebrae, the body is what we consider the anterior elements of the vertebrae. And then everything else behind the body, the pedicles, lamina, spinous, transverse processes, all of these other structures, these over here are all considered posterior elements. We're going to talk about these structures. I'm going to skip in our notes to our diagram of our lumbar vertebrae. We'll also use our other diagrams to look at these structures. We'll look at a superior view initially, and then our other diagram has a superior view and a lateral view. It's always good when you study these diagrams to have opposing views, to have like a top view and a lateral view. That'd be the same as if you were reading an x-ray. You'd always want an anterior to posterior or posterior to anterior view, as well as a lateral view. You want opposing views of these bones. Okay? So we're going to skip all the way to a lumbar vertebrae. That line that I just drew in the notes, we can draw right here. Okay? Here's the body. This is the large block portion of the bone. This would be the anterior structure. So this is all anterior below this line. Everything above this line would be posterior. Okay? Now, this is a superior view of the vertebrae looking down on top of it. Body's in the front, and all these other elements are on the posterior side. Now, L5 is the largest vertebrae in the spine. Then as you go up the spine, the vertebrae get smaller because they carry less weight. So all vertebrae have the same structures. They have a body. This is the weight-bearing portion. This is kind of an oval structure that actually has a little concavity behind it, as you can see right here. This concavity allows for more space for the spinal cord within the vertebral foramen. The vertebral foramen is present in all bones, and when you stack them up together, you have this vertebral canal where the spinal cord runs through. So the front of the vertebral foramen is the body. On both sides of the vertebral foramen, you have these structures called the pedicles. The pedicles attach all of these posterior structures or elements to the body. The pedicles then come back and they will then join with these structures right through here. And the structure here is called the lamina, and I'm going to shade that in blue. The lamina is not just this ridge right here, it's this whole bony plate here. And when you get in the lab tomorrow and you start looking at the vertebrae and studying these lumbar vertebrae, you're going to see these bone plates or sheets, if you will, on both sides. Now, in embryological development, we get this thing called a notochord that ends up becoming the spinal cord. We get a bone nodule or scaffold that starts as the body and then wraps itself around and folds around the spinal cord and fuses in the back. There's a few growth plate or fusion sections, the pedicles to the body, the pedicles to the lamina, and then the lamina come around and fuse to form the spinous process. So posterior elements, we have our two pedicles, we have the two lamina. From the lamina and pedicle junction, we have these two processes that come out on the sides called the transverse processes. So you have one on the left and the right. Then where the lamina fuse together, they form this process that sticks out the back called the spinous process, and we only have one of those. Okay. The last two structures, or few structures we need to talk about, are the superior articular processes and facets, and the inferior articular processes and facets. So for that, I'm going to look at a lateral view on our diagrams that I gave you. Look right here. So here's our lumbar vertebrae here at the bottom. Okay. This is a superior view, but this time on this diagram, instead of the body being down, the body's turned up. So if we look at this superior view to review again on the lumbar vertebrae, 30 is pointing to the body of the lumbar vertebra. 29 is tagging the vertebral foramen. 28 is coming down and pointing to the pedicle. 27 is coming down and pointing to the superior articular process. We're going to talk about that in a second. So I'm going to put SUP and then articular process. 26 is pointing to the transverse process. Okay. 25 is pointing to the spinous process. I'll also let you know, since we're talking about these structures, the transverse process, a lot of times we abbreviate as a TP for transverse process. In a spinous process, we abbreviate as SP because we'll talk about those processes quite a bit. 24, if we skip over here, this is the lamina. And then 23 is pointing up here to this flat surface on the superior articular process, and this is called the superior articular facet. Some people also pronounce that facet. But usually the pronunciation of that, when you just talk about the individual structure, you call it a facet. That's a flat, smooth surface. Facets are also seen on diamonds. You see like the angles cut on diamonds, those are called facets, the flat, smooth portion. When you combine these facets between vertebrae, they form these joints that we can see right through here on the vertebrae. Then these are called a facet joint. So a facet when it's by itself and a facet joint when it's articulated together. Okay? So let's talk about superior articular processes. Actually, let me finish these last two here. So that is right there. So this structure right here is the pedicle on the lateral view. And then 31 is the inferior articular facet. Some other structures I'll tag here on the lateral view, that's that spinous, so I'll put an SP. We can see our transverse process is tagged on both. I'm going to put a TP. This right here is the body. Okay. Now let's talk about the superior articular process. Now, a process is a piece of bone or an arm of bone that sticks out. And so, if I'm a lumbar vertebrae, and these are my superior articular processes that stick up, they're rough, and they have these little tubercles and basically bumps for attachments of muscle. If I turn the vertebrae around, the superior articular processes on the back sides facing kind of posterior are these things called superior articular facets. This is the posterior because here's the spinous process. These facets are the smooth areas for articulation that are present there. So I'll make note real quick that with our facet, I'll write it over here to the side. This is a smooth surface for articulation. Okay? And that's what that facet is. Now, what I want you to know about the superior articular facets of all vertebrae, so we'll put superior articular facets face posterior. Okay. These come off the top of the lamina pedicle junction. the processes do, and then the facets are on the posterior side. Now, on the inferior articular process, this inferior articular process comes down more like this. And so the arms or process has the bumps on facing posterior, and then the inferior articular facet, which is number 31, faces anterior. So we'll put inferior articular facets face anterior. I'll show you this more in lab tomorrow, but if you have a superior articular process that comes up with the facets that face posterior, if you put a vertebrae on top of it, the inferior articular facets of the vertebrae above are going to articulate, but they face anterior, so they'll match up like that. Okay, and it's like a little jigsaw puzzle, and that's how that structure works. Okay. Now, before we get into thoracic vertebrae, because we're going to go thoracic and then cervical, lumbar are typical vertebrae. These are the best ones because they're big. They have larger structures that's easier to see. But these structures then are transferred to the thoracic vertebrae and then also to the cervical vertebrae with some variations, just minor changes. Again, thoracic vertebrae, lumbar vertebrae, they both have a body. They both have the pedicles. They both have a spinous process. They both have transverse processes, even though the structure changes a little bit. Here are the superior articular processes with the facets here on the lumbar. Here they are on the thoracic. Here's the lamina on the thoracic. Here's the lamina on the lumbar. So when you look at these, there's some changes in size and some length of structures, like the spinous is going to be longer in the thoracic and point down than in the lumbar. But for the most part, these are pretty much the same bone. The only difference we're going to see, and we'll talk more detail about it in the thoracic lecture, is we're going to have these articulating facets for the ribs that are going to be added. One more thing, and then we're done for today in this lecture. I want to talk about this pedicle on the lateral view. We're going to have these arches. I'm going to put one in pink, and then I'll go ahead and put one in green right up here. And this will come back, and we'll talk more about these when we start stacking these vertebrae together. But this pink arch or notch is the inferior vertebral notch. I want you to add that. I believe that is on your responsibility list. Then this green one is the superior vertebral notch. And when we start stacking these up together, the inferior vertebral notch of the bone that sits on top will then create this opening with the superior vertebral notch of the vertebrae below, and it causes creates what is called an intervertebral foramen, or IVF. So we'll put in our notes that superior and inferior vertebral notches make the intervertebral foramen. This is also called the IVF. Cool. All right. That takes us through, if we go back, as you're writing that down. Is everyone okay with the diagrams that are up here? You good? All right. So if we scroll up here to the spinal model, where the spine is all together, I just want to point out real quick, you can see the IVF, or intervertebral foramen, from a lateral view. So right here, if we take these bones right here, so here's T1, T2, we can work our way down. Let's do 3, 4, right here at 5. At T5, T6, I have this IVF that's located right there. And that's the IVF between T5 and T6. And that's made up by the two vertebrae coming together. We can see that throughout the entire vertebral column, but that's where our spinal nerves come out and exit the spinal cord. Okay? Good deal.